Okay, this is lesson 9.1 and we're going to call it A in intermediate algebra. And the name of this section is called rational exponents, and you're going to need to get really familiar and comfortable with rational exponents. And so to get started with that, we're going to talk about square roots. And you've already done square roots to know that the square root of 9 is 3, square root of 25 is 5. So what number multiplied by itself is going to give me 9? What number multiplied by itself is going to give me 25? The cubed root of 8 means what number multiplied by itself 3 times is going to give me 8. Cubed root of 64 is going to be what number times itself 3 times will give me 64. The fourth root of 16 is what number times itself 4 times will give me 16. So these roots here, we can have lots and lots of roots. We can go as high as we want as far as the root goes. But a couple things I want to bring to mind, and let's put the same thing on here. This number right there is called the index. If there's not an index like that, you assume that it's a 2. You just don't write it on there. Alright, the number in here is called the radicand. Okay, so if you hear me say the radicand, you know what I'm talking about, or the index, you know what I'm talking about. And this little cool sign here is just called a radical sign. Alright, so what do we do with this stuff? Alright, you can take the root of pretty much any number, the square root of pretty much any number, the cubed root of pretty much any number, except what if this were a negative? That means I have to find two numbers multiplied together, the same number, to get a negative 4. Negative 2 times negative 2 is positive 4. Negative 2 times 2 is negative 4, but these are not the same numbers. One's a negative 2 and one's a positive 2. So when you get a problem like this, there is no solution. It's the null set. That's the symbol that means there ain't no answer for that one. But on the other hand, if our index is an odd number, then we can find a negative. Negative 2 times negative 2 times negative 2. Because these two negatives give me a positive 4 times negative 2 gives me a negative 8. So it is possible to get an answer when there's a negative in the radicand as long as the index is an odd number. Okay? If that index is an even number with a negative under there, there's no solution. If it's an odd number, it's possible that there's a solution. So for instance, fifth root of negative 32 that gives me 4 times this negative 2 is a negative 8 times this negative 2 is a positive 16 times this negative 2 is a negative 32. So we get our number back right there. So key thing to put in your notes. If the index is even, there is not an answer to a negative radicand. If the index is odd, there is an answer, and the answer will be a negative number. Okay, so the next part of this is variables under a radical. So if we have the square root of 25, that isn't too hard, that's 5. But what if I have an a to the 4th, b to the 6th? What is the answer to that? Well, there's no index, so it's assumed that there's a 2. So we take the square root of the number, and we get 5. And then we look at each one of the variables here, and we divide this into its exponents. So 2 goes into 4 twice. 2 goes into 6 3 times. and you're done. Okay? Doesn't matter what the index is. Doesn't matter what number this is. You divide it into the variables exponent, and you get your answer. Now let's say that we had 25a to the 5th, b to the 7th. Okay, 25 square root of 25 is 5. We divide this, the 2, into 5, but it doesn't go. So we get 5 divided by 2. That's how we write it, is 5 divided by 2. And the 7 divided by 2. Oops, there's an A. 7 divided by 2. And those are our answers. So notice that we can do something. Well, let's put one like this with a 2 there. Then that equals A to the 5 over 2. So what I did is I just learned how to write a radical as an exponent. Okay, that's a nice conversion to learn. The bottom number is always the index, the top number is always the exponent. So let's say that I have the square root of 8. Well, that has an index of 2 and an exponent of 1, so that can be written as 8 to the 1/2. So any number that is in a radical sign, we can take the radical sign and write it as an exponent. So the cubed root of 8 is going to be 8 to the 1/3, because there's an assumed 1 right there. Square root of 4 is going to be written as 4 to the 1/2. The cubed root of a squared is going to be written as a to the 2/3. So that's the way that we convert from a radical to an exponent. Becomes very, very handy. So also realize that you can go from a radical or an exponent to a radical. Again, that number is the one that goes there. That number is the one that goes as your exponent, which when you don't write an exponent, there's a 1. If I had 8 to the 2/3, that's going to be the cubed root of 8 squared. Okay? So all we're doing is moving the exponents to the right place, or moving the index and the exponent to a different place so that you can write it as an exponent. Alright, so let's continue on with a couple of examples. If I have negative 25 to the 1/2 power, that's going to be this negative. This 1/2 is not on the negative, so it's going to stay there. Okay? Which equals negative 5. Square root of 25 is 5. Put the negative on there. If the negative were in the parentheses like that, the 1/2 applies to the negative. So that becomes the square root of negative 25, and as you know, when you have a negative in here and an even index, your answer does not exist. Okay, so when you have a fraction to the 1/2, that 1/2 applies to both the top number and the bottom. So we would write that as the square root of 4 over the square root of 9 equals 2/3 for our answer. If we had 8 over 27, and that was a 1/3, that equals the cubed root of 8 over the cubed root of 27, which equals 2/3. Cubed root of 8, 2 times 2 times 2. Cubed root of 27 is 3 times 3 times 3. Alright, bringing us to properties of exponents. Let's just go through these 6. Put them down in your notes. When we have a base that is the same with different exponents, and we're multiplying them, it's 2 plus 3. You add the exponents and get a to the 5th. When we have a division, let's say that we have a to the 6th over a squared, That is the same as a to the 6 minus 2, which is a to the 4th. So when they're multiplied, they're added. When they're divided, they're subtracted. Okay, when you have something like a cubed and we square that, there's no sign telling you what to do, so it means we're going to multiply. It's called the power rule. Okay, when there's nothing between them except this parenthesis here, you multiply those. Alright, when we have that, this negative, if you remember right, tells me that the number in front, or the letter, and its exponent are in the wrong place. This is really written as, if you write it as a fraction, it's going to be a to the negative 4 over 1. So as a fraction, that's what it is. But if this negative sign tells me that my a and my 4 are in the wrong place, I put them on the bottom so they're in the right place, take the negative off. When there's nothing on top, you add a 1 there. It's just like if there's nothing on the bottom, you add a 1 there. If I have 2a to the negative 4 over 1, what's in the wrong place? The letter or number in front and its exponent. The 2 is not in the wrong place. There's no negative on that. So that would be written like that. Now, if I had a 2a to the negative 4th, now this negative is on the whole thing. So now the 2a to the 4th goes on the bottom. Alright, what if I had something like, come on, go away, 2a to the negative 4th over 3. The only thing that's in the wrong place is this there. So everything else stays the same. Just the a to the 4th moves to its correct place. And that's your answer. Okay? Very important to remember that. Alright, continuing on with these properties. If I have something like a squared over, now let's try it this way, a over b to the 4th power, that equals a to the 4th over b to the 4th. This 4 goes on each one of these individually. Okay, so that's it for those 6 properties. And we're going to start with example number 15. Okay, so a real easy way to do this is to write it without the radical sign. And then reduce. 6 over 3 is 2, 12 over 3 is 4, and you're done. The book does it a lot different than I do it, but that's all you're doing, is writing each one of these as a fraction. Alright, so let's say we have 4 square root of 81, and then we have x to the 8th, y to the 20th. That doesn't look like a very good 8. Okay, then we divide. First of all, we take the 4th root of 81. 3 times 3 is 9, times 3 is 10. Okay, so 3. You just have to know those. And then we divide. Alright, so x to the 8 over 4, y to the 20 over 4, and that equals 3x squared y to the 5th. And we're done. So you don't do anything to this. You just take the 4th root of it, and then that will follow along. The ones with the variables are the ones you work on. Alright, we'll continue with the next video, 9.1b.